Hello grade 10s. This is a quick workthrough of question 9 of exercise 13 in your textbooks, just to give you an idea of how to approach these questions. Okay, let's take a look at what's given to us. It's important to read. They tell us that the current on the ammeter is 2 amps. So the current here is 2 amperes and the cell is marked as 12 volts. So I know I have 12 volts of potential difference. Okay. Let's take a look at what happens to the current if we follow it using our finger, like I showed you in the initial video. The current flows through here. Here it doesn't branch, that's a voltmeter, it goes straight. At this point there is a branching of current, right? And then it connects at this point again. It flows up, straight through this resistor, back to the end. Right. So that's the scenario. The current splits up here. What happens between the 6 ohm and the 18 ohm? Remember, the largest resistor gets the smallest current, but that'll be addressed in a later question. 9.1, determine the combined resistance of the parallel sets of resistors. Remember, when we deal with parallel resistors, we have the following. We add them inversely as follows, right? 1 over 6 plus 1 over 18, like that. Just make sure that you first write down the formula. 2. So 1 over 6 plus 1 over 18. That gives me 4 over 18, right? Which is the same as 2 over 9. But remember, I'm just going to rewrite it. It's 1 over Rp is 2 over 9. We flip those two around, and then my parallel resistor is 9 over 2, which is 4,5 ohm. Just to show you how one does it on the calculator, let's take a look here. I will just say 1 over 6, right, plus 1 over 18. My calculator automatically puts it as 2 over 9, which is what we got. But we want the inverse of that, so I press the button here at the top, the x inverse there, and I press equals, and it's 9 over 2. Just press your SD and 4,5 ohm. That's how you would do it on a calculator. Good. 9.2, calculate the total resistance. Wrong. Our total, there's a 1 ohm here, right, 0,5 ohms, and then my parallel one. So it's 1 plus, what is this big one equal to? We just calculated, it's 4,5, and the smaller one is 0,5, so my total answer is 6 ohms. That is how we calculate the total resistance of my circuit. 9.3 tells us calculate the current flowing in the 18 ohm resistor. Now this is going to take a few steps more than usual, right? But just bear with me, and everything should make sense if you know your rules and you understand what's going on. So the current here splits two ways, and we want to know what's the current flowing through the 18 ohm resistor. Okay, well, remember, we're dealing with three things all the time. We have our resistance, our potential difference, and our current. They give us the resistance, it's 18 ohm. We don't have the potential difference yet, but we can get it, okay? Because we want to calculate the current. So to calculate potential difference, it's current times resistance. What's the current flowing through this entire section? Well, we know that it's 2 amps. Even though it's split up, the total current stays 2 amps. What's the total resistance of this section? We just calculated it as 4,5 amps. That's the parallel resistance, which gives me 9 volts. That means that the potential difference, let's just quickly focus in here, we zoom in a bit on this section here. What did we just calculate? We calculated that the potential difference here over both of them is 9 volts. Well, that means that the potential difference over one of them and the other one also is 9 volts. That's one of the properties of parallel resistors. So now we can go calculate the current flowing through my 18 ohm. Alright, I hope that makes sense to you. You must follow along. Right? So we now know, and I'm going to just zoom out a bit again. We know that we want to calculate the current, I, is equal to potential difference over resistance. And the potential difference is 9. And the resistance is 18. 9 over 18, well, we know that one. That's 0,5 amps. Alright, then for interest's sake, the total current is 2 amps, right? At the bottom, 0.5 amps will flow through. At the top, well, 1.5 amps will flow through it. Okay, why? Because 0.5 plus 1.5 equals 2. And that's how we know that. I hope that makes sense to you. You guys must communicate if you're not understanding the work. Because this exercise of studying on your own with just some help from me is really good for you to develop your learning skills, all right? Don't see it as a burden, see it as an opportunity to develop yourselves, ladies and gentlemen. Okay, I think there's a next section, 9.4. If the reading on V1 is 1 volt, what would you expect the reading on V2 to be? So let's just jump back. Let's tell me, what would I expect if this reading all the way up here is 1 volt? What would this one be? Well, here is 0.5 ohms and here's 1 ohm. Double the resistance will mean double the voltage, but we can calculate that, right? V is equal to I times R. What's the current flowing through that? It's 2, and the resistance is 1. 2 times 1 is 2 volt. As expected, 1 volt, 2 volt. Double the resistance, you get double the potential difference with the same current. And lastly, what is the potential difference over the parallel set of resistors? It's 9 volts. We already calculated it. Okay. They're asking what is the potential difference over the set of parallel resistors. I hope that helps. Please speak up if you don't understand. And let's get through this section. We're going to be doing lots and lots and lots of electrical circuits.